In this video, we'll briefly look at calculating the mass percent. When we calculate mass percent from a chemical formula, what we're looking for is we're calculating the percentage of mass of a compound that comes from each of the elements in the compound by using a couple different equations. So we're figuring out how much of that compound's mass is attributed to each individual element. So we can figure out the mass percent of an element X by having the numbers of atom X in the formula multiplied by the atomic mass in atomic mass units. So let's say if we had water and I wanted to figure out the percent for hydrogen, X here would be hydrogen. So we'd have 2 hydrogens times the atomic mass of hydrogen times that 1.01 AMU. Then we take that number and divide it by the molecular or formula mass for that compound. So for water, the formula mass is 18.02. And then we'd multiply it by 100%, which in our case here for water gives us 11.2% of the mass of water is attributed to the hydrogens. And then the rest of the mass for water is attributed to the oxygen. So we can figure this out using AMUs, or later on we can figure it out using the molar mass, the grams per mole. So then we can use the mass of the element as the number of moles of that element multiplied by the molar mass, divided by the mass of 1 mole of that compound, times 100 again. Either way here should give you the same answer. So looking a little more at the mass of an element from its mass fraction. Once I know the mass fraction, I can use that to calculate the mass of a particular element in any compound. So an element will always constitute the same fraction of the mass of a compound. This is part of our law of constant composition, which states any compound will have the same ratio of atoms within it. So that means water will always have 2 hydrogens and 1 oxygen. You're not going to end up with a water molecule having 3 hydrogens and 1 oxygen, or 2 hydrogens and 2 oxygens. When we change the number of elements in the molecule, we change the identity of that molecule. So this means we can always figure out what the mass of the element is from its mass fraction, thanks to our law of constant composition. So that means the mass of an element, if I take the mass of the compound, I can multiply it by the mass of that element in 1 mole of the compound and divide it by the mass of 1 mole of that compound. So that way, if I want to figure out the mass of any element, I'd simply take the mass of that element, or the mass of the compound, multiply it by the mass of the element, divided by the mass of the molar mass of the compound. We're going to do something a little different. We're going to figure out what the mass of that compound is, because we know what the mass of the element is. So if I want to figure out the grams of sodium in sodium chloride, if I know what the mass percent composition of sodium in sodium chloride is, it's 39% of the weight is sodium and the rest is from the chlorine. If we want to double check that mass percent composition of the sodium in the sodium chloride, I know that each sodium is 22.90 grams per mole, and each sodium chloride is 58.44 grams per mole. If I multiply that by 100%, once we do our calculation, we end up with that 39%. See, it works out. So now the question is, how many grams of sodium chloride can you consume while still being within the FDA guidelines of having 2,400 milligrams of sodium per day? We can figure that out. So first we're going to take that 2,400 milligrams and convert it into grams. So remember, we have 1 gram equals 1,000 milligrams. we end up with 2.4 grams of sodium. So now I'm going to take that 2.4 grams of sodium and use my conversion factor here to convert it to grams of sodium chloride. So for every 100 grams of sodium chloride, 39 grams of the mass is sodium. So this is how we can use our mass percent as conversion factors to figure out how much of a different element we have, or in this case, how much sodium chloride we can eat. So here my two sodiums cancel out, leaving me in just grams of sodium chloride, which gives me 6.2 grams of sodium chloride I'm allowed to eat per day, or that you guys are allowed to eat per day. So as you can see, we can use the mass percent of an element as a conversion factor when we're doing our calculations. If we had a certain amount of sodium chloride, I can figure out how much sodium is in it, or I can also figure out how much chlorine is in it. And we can do this for any compound. All we have to do is figure out what the mass percent of that element is in the compound, and then I can use it as a conversion factor when I do my calculations.